Hello, my name is Mr. Manzke. I'm the geometry teacher. We're going to go through some exercises. This is Unit 1, Day 2, and this is page 7. Alright, so the directions here, they want us to use a protractor to find and measure the angle to the nearest degree. Now, some of the shapes, some of the angles are in a position where that's not very convenient. So what you want to do is you can just kind of either you move the paper or you move the protractor, but one of the sides have got to start at 0. Now in this example here, you want to make sure, that you put the upside down T on the vertex. Make sure that this is on 0. It would help if it was like on the right side up. And again, if you need to extend the line a little bit, you can do that. Okay. All right, so we got 0 there. And again, see how this line is a little too short? I'm going to extend that line. Whoops, that was not good. Sorry about that. All right, so we're going to start at 0. Okay, so we're going to go there, up on 0. So again, we're going to, because it's opening to the left, we're going to use the outside numbers. You got 20, 40, 60, here's 70, and here's 80. Now, if I'm looking at this, about 75 is about right here. So we're a little less than that, so we're going to say this is about 74. So I'm going to put a 74 degrees. So this is 74 degrees right here. You put it like in the corner. Okay. Now if we take a look at the next one, we want to find the measurement of IBM. Now again, this one, the position of the angle is just really inconvenient. So let's just turn the paper upside down. You can do that. Okay, and we're going to look for the angle here. Okay, there you go. Okay, and there you go. So, take a protractor, put it on the vertex. Still got to go on B. Even though this is upside down, that's okay. Because it's upside down, it's opening to the right, so that's all right too. So here's the vertex. We're going to put it on 0. So you're going to count. So 20, 40, 60, 80, here's 100, here's 110. Again, if it's not long enough, just make a line a little bit longer. And that's okay. So let's try again. So we're going to go here. And so here, 20, 40, 60, 80, here's 100. It's almost 110. It's about 109. I'd say it's really close here. So we're going to say 109 is our measurement. Okay, and since it's upside down, we can put 109 here and put degrees. Okay, so the next set of pictures here. Okay, so now we're going to take a look at the next group. And okay, so now we're going to do number 18. We're going to find angle S. Okay, again, sometimes it's just a single letter. Just we can do that sometimes when it doesn't have to, it's not adjacent to another angle. So here in this example, again, just extend the line. So right here, we're just going to extend the line. There you go. Make the dot here. And we're going to start at 0. So you get 10, 20, 30, 40. So this angle right in here is going to be about 40 degrees. So I'm going to write 40 degrees here. Okay, the next angle is SON. So S, O, and then N. So this time, we're going to extend the O a little bit. That that line segment there. Now here, extend these lines. Technically they're line segments, but we're going to extend it. So we got to figure out what this angle is right here. So protractor, this is our upside down T that's going to go here, and make sure that you're lining up with 0. Okay. And so you're going to start, you're going to kind of hold in place, don't move it. So it's opening to the left, so it's going to be the numbers on the outside. This angle's opening to the left, so we'll go like 20, 40, 60, 80, 100, 120. Here's 130. Okay, so 130, 120. So in between there is about 126. So I'm going to put 126 here. That would be this angle. The last angle we got to figure out is the angle NOR. All right, so here's N, here is O, and then here is R. Okay, so I think all the lines that we're going to need for this are in place. So now since NOR is opening to the right, we're going to use the numbers on the inside. Remember the protractor, it's going to go on the vertex, the upside down T, the center of the protractor. Make sure that you're lined up with 0. And in this case here, we're going to count 10, 20, 30, 40, 50, 60. N is about right here. So it's between 50 and 60. Here's 55. So you're looking at about 56 degrees. So right here is about 56 degrees. We can double check. Yeah, 56 degrees. Okay, so 56 degrees would be our answer over here for number 20. Okay. All right. So the next one, question number 21, we want to compare which angle below has the greater measure, SML or BIG, and why. Okay, so we're going to look at the first angle. And what we're going to do is you're going to put a point here. We're going to extend our line. And extend our line here. Okay, so the upside down T is going to go on the vertex. Here is 0. And again, angle's opening to the right, so we're going to start with 0. So you got 0, 10, 20, 30, between 30 and 40, so about 35, 34. It's a little less than that longer tick mark right here. Like here would be 30, 31, 32, 30. So I'd say about 34 degrees. And now big. Okay, so here's where vertex, BIG, I is the vertex. Okay, so you're going to start at 0. Okay, and you go 10, 20. It's a little bit more than 20. It's about 21. So I'm going to put a 21 here. Okay, so the question is, okay, which angle has a greater measure? And the answer would be SML. This is 34, this is 21. And the question is why? The reason why that this angle, SML, is a greater number because it's wider apart. As you make this side, if you widen the two sides here, the angle measurement's going to be bigger. Versus if you look at the other angle, BIG, the two sides are closer together. All right, so this last part here. Oops, sorry. So the next set of exercises, they want you to draw the angles for 22, 23, and 24. So the first angle we're going to draw is angle A. So we're going to make a point. We're going to call that A. Okay, I don't need to worry about any other points. draw a ray. You can go left or right. We'll practice both. Okay, now 44. So we got to find, so upside down T on the vertex. Make sure that the line is on 0. Okay, and then we're going to count 10, 20, 30, 40. So it's got to be between 40 and 50. 45 would be about right here. One tick mark lower than that would be 44. So I'm going to put a little dot here. And there. Okay, so that would be 44 degrees right here. Okay, the next one. This one is angle B. Okay, so it's 90 degrees. So let's draw a vertex. We'll call it B. You're going to draw a ray. Put the upside down T on the vertex. Make sure it lines up. Put that there. Now this one, we want it at 90. So let's count by 20s. 20, 40, 60, 80. Here's 90 right here. So we can put a little tick mark. And you're going to go up and down. So just for future reference, anytime that you're dealing, that was a little off. I was a little off on that. 90 degrees is the measurement right here. We'll talk more about right angles later, but it's going to always have an L shape. Okay, the last one. Now here, if you look at our last example here, CDE. Okay, so it's got to have 3 letters. The middle letter is what we're going to start with. So that's the vertex. So we're going to call that D. And then what you're going to do is you're going to draw a ray. Now DE would be one of our sides here. Okay. Put the upside down T on the vertex. Make sure you line up with 0. And then we're going to count, we'll go by 20s, 20, 40, 60, 80, 100. 120, 130. So 135 would be between 140 and 130. Let's just move this over a little bit. There you go. So here's 130, here's 140. So in between there, 135 would be about the halfway point. So they use those little longer tick marks there, which is kind of convenient. And don't worry about extending the line. Just go as far as you need to. Now we got to need another point. We need C. We got D and E, so somewhere along the line here, it doesn't matter where you put it. So let's put a dot on C, so you want to make sure that you're accurate. And then the measurement here is 135 degrees. Okay. All right, so that was page 7. Thank you for watching. Appreciate it. Have a nice day.